Organic chemistry, nature of bonding, and stereochemistry. Topic name is aromaticity. These are the learning outcomes of this lecture. So here we will see the aromaticity of six-membered cyclic species. So as we know, there are two conditions for aromaticity of a compound. First condition is the compound should be cyclic, planar, and it should have conjugated double bonds. And the second condition is that the compound should have 4n plus 2 pi electron. So now we will see whether the six-membered cyclic species are fulfilling these conditions or not. So let's take the example of benzene. So in the case of benzene, this is benzene, okay. So if we see the first condition, this benzene is cyclic also, it is planar also, and it have three conjugated double bond also. So the first condition is fulfilled, okay, and these double bonds are delocalized. Now, if we see the number of pi electrons which are taking part in delocalization, there are 2 pi electrons in each of the three double bonds, and hence we have a total of 6 pi electrons. So, the second condition is also fulfilled. So, this benzene ring is aromatic. Now let's see the aromaticity of seven-membered cyclic species. So here we have three pictures, okay, three compound. So first is cycloheptatriene, second is cycloheptatrienyl cation, and this is third one is cycloheptatrienyl anion. So here we can see that the first compound, that is the cycloheptatriene, it is not fulfilling the first condition. It is cyclic, it is planar, but it does not have the double conjugated bonds, okay. Alternate double bonds are not present here, so it is not fulfilling the first condition. So this is non-aromatic. Also it is not fulfilling the second condition. Now if we will see the cycloheptatrienyl cation, it is fulfilling the first condition. It is cyclic, it is planar, and it also have the conjugated electrons, okay, or we can say conjugated double bonds. So it is fulfilling the first condition, and the second condition, that is we should have 4n plus 2 pi electron, so it is also fulfilled. Here we have 6 pi electron, so this is aromatic compound. And if we see the third compound, that is the cycloheptatrienyl anion, it is anti-aromatic because it is fulfilling the first condition, but it is not fulfilling the second condition. It is having 8 pi electron, so this is anti-aromatic, okay. So here this cycloheptatriene is cyclic and planar, but one of the carbon is saturated here, this one is saturated, and it does not possess a p orbital, okay. So this so here we have seen the aromaticity of seven-membered cyclic species. Now let's see the aromaticity of fused polynuclear hydrocarbons. So here we have naphthalene, anthracene, and azulene. So if we will see the first condition of all the three compound, it is fulfilled, and in the second condition also the naphthalene and azulene are having 10 pi electron, which is fulfilling the 4n plus 2 pi rule, and anthracene has 14 pi electron. It is also fulfilling the 4n plus 2 pi rule. So all the three compounds are aromatic. Now let's see the aromaticity of substituted cyclic species. So in these kind of compound, don't consider the double bond which is out of this cyclic ring. In this first compound, that is ethynyl cyclobutadiene, we have two double bond here in this cyclic ring and a double bond outside this ring. So while seeing the aromaticity of this compound, we don't have to consider the double bond which is out of this cyclic ring. So here we have only two double bonds, okay. So if you will see the aromaticity of this compound, the first condition is fulfilled, that is this compound is cyclic also, it is planar also, and it is also having the conjugated double bond. But it is not having 4n plus 2 pi electron. Okay, so it is not fulfilling the Huckel rule, so it is anti-aromatic. Now if we'll see the second picture, in this second compound, that is ethynyl benzene, it is aromatic. Why? Because it is fulfilling both the condition, that is it is cyclic, planar, it is having conjugated delocalized bonds, and it is also fulfilling the Huckel rule. So we have talked about substituted cyclic species and aromaticity also. Now let's see the aromaticity of cyclodecapentaene. So here in this compound we have 10 carbons, okay, and this compound is cyclic, okay, and it is also having alternate double bonds. It is also planar. In this picture it is looking planar, but it is not the actual case, okay. Its actual figure is like this, and in this figure we have 3 cis double bond, 1, 2 and 3, and 2 trans double bond, 1 and 2. So if we look closely, we will find that the two hydrogen atoms on the 2 trans double bond come very close to each other, and thus the molecule is actually existing in a manner where the ring becomes puckered, or we can say non-planar, so that the two half cyclic rings are tilted in order to make these two hydrogen atoms slightly away from each other. So I'll show you this condition in this picture. Here you can see the molecule puckers to keep these H further away from each other. So here this picture is not planar, okay. So aniline is not fitting in Huckel rule, so it is not aromatic. It is fulfilling all the condition except the planar one, okay. So due to non-planarity, the p orbital on the 2 half cyclic ring also becomes non-parallel, and hence there is no continuous delocalization. So this molecule aniline is not aromatic as it is non-planar, as well as it is not having continuously delocalized pi electron, if you will see this picture. Although it is cyclic and has alternate double bonds and single bonds, and it is also having 10 pi electrons, but it is not planar. So aniline is not aromatic. Now let's discuss the MCQs related to this lecture. So first question is, identify the incorrect statement regarding aromaticity. So first statement is, it is the extra stability possessed by a molecule. Yes, definitely an aromatic compound is more stable than the other one. Second option is, p orbital must be planar and overlap. Yes, this is a condition for aromaticity. Third is, cyclic delocalization takes place. Yes, this is also true, but in the last one it is saying it does not follow Huckel rule, so this is wrong. The second condition we have for aromaticity is that it follows the Huckel rule, that is 4n plus 2 pi electrons. Second question is, select the correct statement regarding the aromatic nitrogen molecule. If we talk about nitrogen molecule, it means N triple bond N, that is N2 molecule. So in this nitrogen molecule we have 3 bonds, means the triple bond. So this is sp2 hybridized. So option C is correct.